Hi, welcome. This screencast is a continuation of building a Google Compute instance with Terraform. Terraform does a wonderful job of creating consistent infrastructure. Now it's time to use Inspect and Kitchen-Terraform to verify the results of the Terraform run. We should still have a running Google Compute instance. Let's inspect that with Terraform show. So it comes out with what it has in the current Terraform state, which is the link between the real-world resources and the Terraform code. Let's dive in. What we first need to do is build out our test fixture. This test fixture will be Terraform code that calls our Google Compute instance code as a Terraform module. Let's first create a directory called test fixtures tf module. And after that, we need to create a main.tf file. In here, we'll create a module block. We'll call it what we call our Terraform module, Terraform Google instance. And then the source is referencing the root directory of this Terraform code repository. Our next step is to create the integration tests Kitchen-Terraform will help run against our infrastructure provider. Let's make a directory of test integration kt suite controls. Now we need to create a inspect profile, and we'll keep it very simple, and we'll just call it default. And we'll save that under the kt suite folder. Now let's create our first inspect test. We will save a file called default.rb. It will be under controls directory. We first create a control context block. We'll call it instance. These control context blocks are a good way to link compliance controls with your tests. Next, we're going to have to get some information from the Google Compute command line client. This will help us understand what kind of tests we need to run and what kind of validations we can use. Let's go to G5, Compute, Instances, and describe the database instance. We can use the output of this command to verify our expectations have been met. There's going to be a lot of output, so let's look at the items we can duplicate or validate. Should make sure the name is database, as if that changes, the instance will be destroyed and recreated. Let's just add notes there, comment them out. Let's see what else we can do. Oh, in regards to the name, testing for the name change is simple, but it's effective. As I'm sure many of you are aware, how standard naming conventions change over time at most organizations. And here's another one we should check. So we have the metadata block, and then we have the SH keys. So we'll just check to see if the key is there. Let's do one more. I like the status is running. Most of the time I like to make sure the instance is running with the tests because at times configurations could be misaligned from certain parameters that don't work well together. It would be a silent error that would most likely burn us in a real environment. Now that we have some of the outputs we'd like to see, let's create a describe block with a command resource. And the command is going to be the same one we just were outputting. And inside of this is where our assertions will be for the test. So it's saying this command, and then we're going to also write its standard out should match name database. That one's done. And we'll do the other ones too. Copy and paste this one. And the last one. Let's stand it out. Should match the status of running from the output of that command. With our inspect test and Terraform code out of the way, we need to set up the Kitchen-Terraform framework. To do that, we need to create a gem file in the root directory of the repository. In this gem file, we need to create the source, download the gems, which is rubygems.org, and then we call out a single gem, Kitchen-Terraform. Now, we can install the gem by running Ruby's bundler utility. Once that's running, I'll go on to the last step, which is to create a kitchen.yaml file. What this does is it essentially pulls together the integration inspect test and Terraform code. So in the root directory, I'm going to call it .kitchen.yaml. The first section we need to create is the driver. This tells Kitchen to use the Kitchen-Terraform plugin. Another item we need is the root module directory. This references the Terraform code we just created under test fixtures tf module. Next, we must tell Kitchen to use the Kitchen-Terraform provisioner. Now it's time to tell Kitchen to use the Kitchen-Terraform verifier. And then we'll create inspect control groups that we created earlier. The group name is the reference to the file default.rb under the test integration KT suite controls directory. We're also going to pass in the controls we want to run. In this case, we have one control, which is called instance. And if you remember, default.rb has a control called instance. The next section is to configure a kitchen with a suites block. It will look simple for our example, however this is a very powerful tool. For example, if you needed to create additional infrastructure for your Terraform code to depend on, then you can create more suites and run that code first before running the code you need to test. So for this code, we're going to have one suite, and it's going to be called KT Suite, which is a reference to the folder that stores the inspect tests under test integration directory. The last item is to tell Kitchen to use the Kitchen-Terraform as the platform. Our instance is still running, so let's use the Terraform destroy command to remove it before the tests start. The destroy command is the opposite of the apply command, where it takes anything inside Terraform state, looks at the Google provider, and determines what to destroy. So in our case, we have one thing, which is the Google Compute instance of database. It always asks if it's a yes or no to destroy, just like apply. And so you can see it's still destroying. It takes a little bit sometimes. The destroy is complete, and we have one resource that was destroyed, just like it said. Now I'm going to open up my command prompt a little bit more here, because this is the exciting part. Let's run the test. So Kitchen has phases, which Kitchen-Terraform has associated to Terraform phases. So let's list out our test suites first with Kitchen list. As you can see, we have a KT suite with the driver, provisioner, and verifier all being Kitchen-Terraform. So let's go on to the first phase, which is going to be Kitchen Create, which will initialize a Terraform workspace for our test suite to run in. And you'll notice this is Terraform output if you were to run this Terraform commands yourself. From here, we need to go over to the second phase, which is Kitchen Converge. This runs Terraform get, validate, apply, and output. And just like before, the output will be Terraform's output, but it's all running in an automated fashion. You don't have to say yes or apply or anything like that. Now our test Google Compute instance is being created. and we'll go on to the third phase, which at this point is called Kitchen-Terraform. This iterates through the groups and executes the proper inspect controls. So now we're no longer using Terraform for this phase, and we're using inspect. The output will be inspect's output, not Terraform's. And this is where we'll see our 3 tests we created earlier. So we have an output. We have 3 tests that have passed and 1 control. The control is the instance, and then we have 3 tests. The standard out of that command should match name database, key SSH keys, and status of running. Once that is done, the fourth and final phase is kitchen destroy. This runs Terraform init, selects the proper workspace, and then runs Terraform destroy. This deletes the test suite's workspace also. And you can see this is Terraform output again. And you can see that it is destroying the Google Compute instance of database. Well, we have now destroyed everything, and we are complete. Now that was a way to run through each kitchen phase one at a time. However, for CI/CD, you can run bundle exec kitchen test, and that would run through all the phases for you and output with a failed or a good mark depending on if your tests were successful. And there we have it. Fully tested Terraform code to help maintain our Terraform modules, scale our engineering efforts, and begin to implement a fully automated CI/CD pipeline. Congratulations! These tests have increased our confidence in our Terraform code.